So let me show you some aspects about two of the flownet files that I think will be worth noting. So if we go and open up this dam flownet problem, and we need to go and put a new modflow package on here. We see the starting heads are 0, and so we need to change that to 1. The bottom elevations, here the bottom elevations are 0. Let's just try this. So I'm going to not change the bottom elevations, and we'll go here to we'll map it, and then we'll check the simulation. So yeah, there. Warning, bottom elevations are all 0 in layer 1. So we don't want that. So we'll go and fix that. So here we go to modflow, see the global options. Get back to that page, and it'll be bottom elevation, and we'll use this constant to grid mapping again, and we'll make it minus 0.5. It doesn't really matter so long as it's not 0, and as long as it's negative for this particular problem at any rate. Okay, so there we go. Now this is the problem of the dam, and there's this core of the dam like so, and the flow is going to go underneath that. So what I've done here is to put in this polygon right here that'll have lower hydraulic conductivity than the rest. So we'll go ahead and do the mapping, which I guess has already happened. We'll just do it again, and then what I want to do is show you how that is expressed. So what I did here was click on HK, that's horizontal conductivity. And what you see here are these two colors. Blue is conductivity of 1 unit, and red is 0. It's not actually 0, it's a low value, and we can see here how that's set up. So under the conceptual model for the dam, I have K, and then I have low K core of the dam. So if I click on that and click on this, then there's a hydraulic conductivity for the low K core. And then if I click on this K and click over here, that's the hydraulic conductivity of the rest of the region. Okay, so here's what happens when we do that. If we run this, I'm going to save this under a new name. And then we run it. Looks like it runs okay. And here are the results. And you can see where the equipotentials are kind of kinked here. That's because of the change in the hydraulic conductivity right in this region. And we can see that that's in the region of this low permeability core. If we go and click on the head and then go to display and go to contour options and make the head contours somewhat transparent, there you can see the core of the dam that we've identified. Okay, so let's see what effect it has, what that low permeability zone has on the flow lines. So we'll go and select, we've got to select points here and press that button to draw some points, and then we'll go in here and put these points in, select them, right click, select them, right click, select intersecting objects, and generate particles. And now here are the path lines. And you can see that the flow paths go around this low permeability core. There is some flow that does go through here, and you can see it's driven by this head gradient. But because of the low hydraulic conductivity, it's quite a low flow, and we don't have any flow lines that are shown here going through that core. Okay, so another thing that I wanted to show you was this model. It's a well on island. This is a very simple symmetric model, and I've already run it here, and you can see how the contour spacing becomes closer and closer as we get towards this center point. The thing that I want to point out is that in this model, what I did was to make an initial grid that is within this purple box, but I set it up so that only the points within this circle are active. Only the region of the grid within this circle is active. You can see these purple dots. That's the constant head boundary. But I have an inactive region of the grid here. It's not, the grid blocks aren't showing up here in this display. But when I made the grid, there were blocks out here. But by the way I set this model up, those regions are inactive. So that's something that we'll do later on when we want to have a region that's kind of irregular shape. We'll inactivate some parts of